Hello, in this video, let's discuss third question of today's contest. You are given a string S consisting of opening bracket and closing bracket and an integer k. A string is k balanced if it is exactly k consecutive open followed by k consecutive closed. For example, if k is equal to 3, k balance is this one. You must repeatedly remove all non-overlapping k balance substrings from S and then join the remaining parts. Continue this process until no k balance substring exists. Return the final string after all the possible removals. N is up to 1if and k is also up to 1if. So given a string, we have to remove k balance substrings. For example, if this is the string and k is equal to 2, then we have to remove substrings with nested two brackets. For example, opening and closing. So this is the string with k is equal to 2 balanced. So remove all this. So return final empty string. And if this is a string, there is no closing bracket at all. So there is no possibility for two length balanced substring. So simply return the initial string. So if this is the given example, then what we have to track first? We have to track the number of opening and closing characters, because only then we can say whether we can remove the substring we are at or not. For example, if we are at index A. So if we are at this index, how can we know that the 4 length substring which is ending at this can form a balanced one? So only if we find that it is balanced, only then we can remove. But how can we first find whether that is balanced or not? And for k is equal to 2, there will be 4 in substring, because 2 opening and 2 closing. So for every k length, there will be 2k length total substring, first k and second k. So at every index, if we have to know whether a balanced substring is ending at present index or not, we have to check 2k length subsequence, 2k length substring. But how to track the number of opening and closing brackets at each index? So even if we try to use some kind of prefix sum, for example, the number of opening brackets from this index is 1, ending at this index, and ending at this index is the before one is also open and this is also open, so this will be 2. And coming to this is also 3, because this is also open and the number of open tail before is also 2, so the net will be 3. And coming to this is the closed one, so we don't care about the previous one, so this is simply 0. So in this way, if we try to simply compute, can we find the number of open and closed bracket in of 1? No, because the things can change them dynamically. For example, we found the answer for the given string, but what if we remove these both? For example, if k is equal to 1, so if k is equal to 1, we can remove these both. So if we remove these both, then number of opening characters at this end will be affected, because before removing it is only 1, but after removing it is 2, because this also will be added for this. So initially it's 1 and now it is 2. So we cannot simply track by static array, because by static array we may remove some balanced substrings and hence the answer can be varied, which is not exactly as per the given string. So now we cannot do that. And now what is the other choice we have? So other very simple choice is, whenever we are at I, we know that we are going to check 2k length balanced substring, 2k length substring to check whether it is balanced or not. Only then we can remove that. So if it is I, what is the index where 2k length will be starting? It will be I minus 2k plus 1. So the given string is I minus 2k plus 1 to I. So we have to check whether first k of these are open and the rest k are closed. If that is the case, then we found a substring, balanced substring, and then we can remove all of these from the given string. So how can I do that? So from that we also got that we want to store something. We want something to store the final string, which will be populated dynamically while traversing. So only a single static string will not be satisfying the given condition, because some letters, some substrings may be removed from S also. So the removal time complexity from a string is of n, because we cannot dynamically remove, right? So we want some other thing to store something, the final string which will be returned. So we can simply use a vector for that. So we can use a vector and then we can use dynamically to populate the opening and closing characters to that. Let's do it here. For example, if k is equal to 2, so the length will be 4. And starting from this. So let's start from the first character. So starting from this. So if we assume that this is ending, like this is the ending substring for a good balanced substring, the length should be at least 4, because the length should be 4. Like the total length should be at least 4, so that we can get at least one string with length is equal to 4. But here the only string, the character is only 1, so we cannot assume that there is any substring and get this. So simply add this into vector, and even for this add this into vector, even for this, even for this. So after adding this, the length became 4. So now we may have to check that whether the string ending at this with length 4 is balanced or not. So how can we check that? So we can simply loop from I minus 2k plus 1 to I. So this is open, this is open, this is closed, this is closed. So we got the condition. So simply remove all these from the vector v, not from the string s. So remove all this from the string, from the vector that we added, because we are adding to the vector as soon as we reach the character. And then if there is any substring which is balanced, then we will remove from that vector. So remove all this and then come to the next character, and that is open. So the net length is only 2, because these 4 are already removed. So there is no way to check 4 length substring. So the length is only 2, so we cannot do anything. So add this also, and then the length became 4. Even now check the condition as before. So these both are open and these both are closed. So simply pop all these 4 from the vector and finally return the vector. Like finally make the string from the vector and return it. So let's check the code and time complexity. So initially use a vector and then start traversing to string, add the character, and then loop through the vector only if the size is more than 2k, because only then we can remove that, right? So bool OK is equal to true. So traverse only if the length is greater than or equal to 2k, and maintain a boolean OK to specify whether the string is balanced or not. So whenever if we find a character which is violating the balance, we'll pop, so that there will be no any unnecessary iterations. For example, let's say we are at length 4, so k is equal to 2, and we came here. So when we reached here, we want only 2 opening and 2 closed. But when we reach this letter, we will get that this is among the first k, but this is not closed, but this is not open. So simply break the loop. So we will just remove here and we'll break the loop and we'll go to next character, because there is no use to check all these whenever this is wrong, because if this is wrong, there is no need to check any of this. So whenever we find a bad one, we will just break them. So traverse for the first k, 0 to k, and I minus 2k. So this is simply the size minus 2k plus a, which will give the this one. For example, if we are at I, this is k. So this we can find the index, right, because we know the length. So if b of I is not equal to this, because for the first k we only want this one, so simply use OK is equal to false and then break, because if that is not that, this means we got a closed one which is violating. So if that is not open, then simply make OK is equal to false and then break the loop. And then if all of these are true, if all of these are k, only then we will check the next k. So if that is okay, only then check the rest of the k. So if that is not closed, then simply OK is equal to false and then break. So after this both, even now we will check if OK is equal to 2. If OK is equal to true now, it means that we found a balanced substring. So only then we are going to remove from the vector. So if that is not, if OK is equal to not true, then simply break the loop. Else start from 0 to 2k and then we dot pop back, because these are the last 2k length, because we checked what is the substring which is which is of length 2k, and which is last substring. So we are going to pop all those from the vector. So simply pop this. And finally, after the loop, then add the vectors, add the characters from the vector to the final substring and return the result. So what is the time complexity? The time complexity is only of n, not of n squared. Because we can pop any character only once. We can pop or we can traverse any character only at most once. Why? Because if the string is valid, we will directly pop it, because there is no way to traverse that again, because we are directly popping it. If this is not valid, even in the future we will not reach this character again. So even if it looks like of n square, but any character is popped or iterated only at most once. So the time complexity is only of n. In this way, we can find the answer. If you have any doubts, comment below. See you in the next video. So let's check the code also. So it's exactly the same. So start from the vector, and then if the length is more than 2k, only then traverse, then for the first half, then for the second half, and then finally go through 0 to 2k and pop back. So if you have any doubts, comment below. See you in the next video.